Okay, let's discuss this question. Set m, n, and k are positive integers, and n is greater or equal to 2, and n greater or equal to k greater or equal to 2. They are the relationship, inequality equation between m, n, and k. Pay attention there. N is larger than k. And the real number. M and k are integer, but the real number x, it's a sequence, and it is decrease. It is larger than 0. Satisfy following conditions. The all conditions is for xi. The different from them is the first condition is xi to the power of m, m is an integer, and the second is for x1 is a linear. And we need to prove that x1 plus x2 blah blah plus xk. There xk until xk not xn is greater or equal to 1. For this is an algebra question. So you always use the basic method, that is contradiction and resize algorithm. It means sometimes we enlarge the number, and sometimes we reduce the number. Now this question, it wants us to prove this greater or equal to 1. So first we use contradiction. We suppose they are less than 1. For combination with this condition, xi is greater than 0. So we can get that xi is less than 1. If xi less than 1, we can get the property that xi to the power of m is less than or equal to xi to the power of 2. And then let's do the resize algorithm, the second step. And it is the most important step for all this question. M to the power of m is greater than 1. We can resize it. We use enlarge. We enlarge every integer here, the real number here. So it is less than x1 square plus x2 square plus xn square. Then we separate it from two parts. The first part, the front part, from x square and at xk square. And the second part, it is from xk plus 1 square and 2xn square. We do the enlarge for them respectively. And this is less than, because x1 is the greatest number here, so we make x1 out. It is less than x1 times x1. And at xk, we enlarge this part. Because xk is greater than all this number, so we enlarge it into xk, extract it, and in front of it, inside of it is xk plus 1 to xn. And we reserve this form. We change this form. What I want to do, the final goal is I want to find the contradiction of them. That means I should to get the conclusion that x1 plus xk that is greater than 1. That's the point. If we get this conclusion, and the statements will hold. So this is our goal, main goal. We should transfer this part into this form. So we continue to enlarge this form, the latter. For this part, we have another condition to use. That is, x1 at xn is less than k. So we get that xk plus 1 at xn is less than k minus x1 at xk. So we substitute it here, we enlarge this part. We still remain this form in front of this equation. And we do a split. We split it into k minus 1 and other one. We exacted it out. Extract it out, and then it is another xk we continue to enlarge. We want this part and this part, and we can cancel each other out, so we enlarge the latter part, and we continue to reserve the front part. Enlarge this one to x2 plus x3 to xk. They are k minus 1 number. There are. And we enlarge this one into x1 to make them the same. So we get it. This part times x1, and this part times x1. This one is positive and this one is negative, so they can cancel each other out. They are left x1 plus x2 at xk. Then we get the conclusion. Finally, this one is greater or equals to 1. This is impossible. So, rearrange statement holds. We accomplish it. Okay, bye bye.